Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.12, Continuity at a Point. To discover what it means to be continuous at a point, we're going to start with the most not continuous function we could draw. Then we'll piece together, one step at a time, what it ultimately means to be continuous at a point. So first, let's look at this function that's definitely not continuous at x equals a. On the left, I'll draw some part of my function that arrives at a, and then starts again on the right and goes over here. So you can see that this guy's got a big jump happening at x equals a, so it's definitely not continuous there. Now, how would we say that this is not continuous with calculus, algebraically? We'd say the limit as x approaches a from the left of f of x. Oh, well, I guess I should give this function a name. We'll call it f of x. We'll say the limit as x approaches a from the left does not equal the limit as x approaches a from the right of f of x. That indicates that we've got a giant gap in our function, a jump. So we know that for our function to be continuous, the limit as x approaches a from the left and the right must be equal. Is that enough? Can I draw a function where this happens, but it's still not continuous? I think I can. If I draw this function, again, as we approach a, and on the left, I'm going to approach a specific y value, and on the right, I'm going to approach the same y value. So definitely the limit exists from the left and the right, and it's the same. The problem is, this function's still not continuous. I still have this hole here, this little gap, so I'm not continuous. Now, if I had to write down algebraically, mathematically, what's happening here, I would say that my function looks like it wants to be continuous, but the issue is I just have this hole. So how do we say that? We just say f of a does not exist. All right, so that gives us part 2 for continuity as well. If I'm going to be continuous at this x equals a value, I better exist there, which begs the question, can I draw a function that has the limit as x approaches a existing and f of a existing, but it still not be continuous? And I think I can. See this last example on the right. Sure, my limit as x approaches a from the left approaches this hole, from the right approaches this hole. I still need f of a to exist, and I'm just going to place it right here above the hole. My function is still not continuous. Right? The hole still is there. I have a point in my function, so f of a exists. It's just not in the right place. So algebraically, with calculus limits, we would say that f of a, the point, is not in the right spot. So f of a does not equal the limit as x approaches a. So altogether, we found 3 issues that would make a function not continuous. First, it has a giant jump in it, where the left and right limits don't equal each other. Next, maybe the left and right limits equal each other, but the function doesn't even exist at the point, so it can't be continuous. And third, the point exists, but it's not in the right spot, so I'm still not continuous. Hence, there are 3 stipulations for continuity at a point, and they are as follows. First, we can't have a giant jump in our function. So definitely the limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the right of our function. Secondly, if my function is going to be continuous at x equals a, I definitely can't have a hole there. The function has to have a point. So second rule for continuity is f of a must exist. Pretty straightforward. And lastly, just because f of a exists doesn't mean it exists in the right spot. It might be up here and not in the hole. So the last stipulation we must follow for continuity at x equals a is we need f of a to be in the hole and not fill the hole. So we need f of a to equal the limit as x approaches a of f of x. And that's it. There's our 3 stipulations for continuity of a function at a point. Be sure to check out the links in the description below to find more videos like this, we're also constantly producing practice AP style questions for you to learn from. Be sure to check out the next video, should be popping up right now, about how to remove discontinuities. Don't forget to hit subscribe and like the page to get alerts about all the content we release each week.